welcome to my channel, and here we are going to be working on the construction of the surface development of a complete cone. As we have a question here that says that figure 7 shows the front elevation of a complete cone. Draw the surface development of the cone using NN as seen. Let me read the question again. Figure 7 shows the front elevation of a complete cone. Draw the surface development of the cone using NN as the scene. Alright, so this is the front elevation of the cone as we are given, and then the diameter of the circular base of the cone is 50 millimeters, while the height of the cone is 60 millimeters. Then the seam is on this line, so we have to cut it on this line and spread it. Alright, so I want to take note of this information that I'm going to give, that whenever we develop the surface of a complete cone, what we get is a sector. So you are going to see how it's going to be done here. Alright, let's start and see how we can make the surface development of a complete cone. Now, the first thing that we are going to do is to draw a horizontal center line, and then it is not compulsory that you start with the horizontal center line. Horizontal center line. I can start with a vertical center line as I want to do it here. So I'm drawing a vertical center line, and don't forget that our center lines are drawn with thin long chain line. Okay, so I've drawn that of the vertical. I'm going to draw horizontal center line like this. Okay, so we have this now. So the diameter of the circular base of the cone is 50 millimeters. That means the radius is 25 millimeters. I'm going to take a measurement of 25 millimeters on my ruler with the compass. So this is 25 millimeters here. So putting the midpoint here at the point where the two center lines intersect, I will draw a circle like this. Okay, so we have this circle drawn. So the next thing that we are going to do is that we take our 60-degree set square and 60 by 30 degree set square, and we are going to divide this circle into 12 equal parts. So you are going to see how I'm going to do it here. So we draw a line in this direction. Okay, and then so we move the set square in this direction, and we draw a line from here to here. Okay, then we turn the set square to this side, and we draw a line through the center at an angle 60 degree. Okay, then we also take it to this side, so at an angle 30. So we draw this line. So we have divided the circle into 12 equal parts. So I want us to number the point on the circle. So this point, I will call it, this is point 0. So you can start from 1. So this is 1, this is 2, here is 3. Okay, this is 4, here is 5. So this is 6, this is 7. So here is 8. So this is 9. So this is 10. And then we have 11. So you can start from 1 to 12. So it's not mandatory that you start from 0. Alright, so the next thing that we are going to do is that we come up a little bit, okay, away from the top view. Then we draw the horizontal line. And then, so what we are going to do now is that from each point that we have on the circle, starting from this 0, so we draw a vertical line to meet the horizontal line, and then point 1 and 11 are the same point on the circumference of the circle, so we draw a vertical line to meet the horizontal line. Point 2 and 10, they are the same point on the circumference of the circle, so we draw a vertical line to meet the horizontal line. So we have drawn that of 3 and 9 as a center line. Then for point 4 and 8, they are the same point on the circumference of the circle, so we draw a vertical line from point 8 to touch the horizontal line. Point 5 and 7, that also at the same point on the circumference of the circle, so we draw a vertical line from 7 to touch the horizontal line. And lastly, so from point 6, we draw a vertical line to touch the horizontal line. So now we are going to take a measurement of 60 millimeters because the height of the cone is 60 millimeters. So from this point here on this vertical center line, I will take a measurement of 60 millimeters. So here is 60 millimeters. So this point I will call it point O here. So this is point O. Okay, so now we are going to, okay, so we are going to join each of these points with the apex of the cone, so which is point O. So I will draw a line from this point to touch point O, and from here also. So I will draw a line, and then from here I will also draw a line from here. Then from this point I will draw a line from here, and from this point I will draw a line, and then lastly from this point I will draw a line to touch point O here. Alright, so then so the next thing that we are going to do is that this line from 6, we are going to make it a thick line. So I use my black pen for that. And also this line, so to this point 0, so we make it a thick line from here to here. Okay, and then so the base line, so we also make it a thick line. Okay, so this is the complete front elevation of this cone, which is a complete cone. Now we have the seam, that is where we are going to cut it from. So we have N at this point as we are told in the question, and we also have N at this point as we are told in the question. Alright, so the next thing that we are going to do now is to go for the surface development. Alright, so what we are going to do now is that we first of all move away from the given views, or from the given view, which is the front elevation. So we draw a horizontal line like this, and then so this point on the horizontal line I will call it point O prime, so to differentiate it from this point O, which is the apex of the cone. Then we take the compass, so we take the compass and we put the pinpoint here at point O here, and we extend to this point on line 0. I don't want to put numbering here. Okay, so we put it at this point. We extend the pencil point to this point on the horizontal line, which is point 0. So just take this distance. Okay, so raise it up and then put the pinpoint here at point O prime here. Okay, then we draw an arc. So we draw an arc like this. Okay, just draw the arc like this. So having drawn the arc, we are opening this cone, we are cutting it here. This is where we have the seam. Okay, so we are cutting it from point 6, so we meaning that this point will be point 6 here. Alright, so then the next thing that we are going to do is that we need to make 12 equal points on this arc. Okay, so based on the division that we did for the circle, we divided the circle into 12 equal parts. So we also need to make 12 equal points on this arc. So what will be the radius of that arc that we are going to make here? So we are going to take the distance of 0 to 1 or 1 to 2 with the compass. Just take this distance like this. Okay, and this method that we are using is a radial line method. Radial line method. We use a radial line method to develop cones and pyramids. Cones and pyramids. While we use parallel method to develop prisms and cylinders, which you have seen how to do, how we did that in the past. Okay, so we take this distance 0 to 1, 0 to 1, and you can take 1 to 2 if you like. So I've taken 0 to 1. So put the pinpoint here at 6 here at this point and make an arc here. So this is 1. Then raise it up, put at this point. Okay, so make an arc here. This is 2. So here is 2, and then we put it here. So this gives us 3. So we put it here. So this gives us 4. So put it here. This gives us so here we have 5, and put it here. So this is 6. So put it here. Here is 7. So put it here. This is 8. Okay, so we put it here. So this is 9. So we put it here. So here is 10. So we put it here. This is 11. And lastly we put it here, and this gives us the 12th one. Okay, so we are opening from what? From 6. So we go around, so we are going to be back to 6. But let's go this way. So this is 5. Okay, so followed by 4. So if we are moving like this, followed by 3. Okay, so here is we have 2, followed by 1, and followed by 0. Then we have 11, so followed by 10. Okay, followed by 9, so followed by 8, followed by 7, and back to 6. So this is how we have it. So the next thing that we are going to do is this. So each of these points, we connect them with point O prime. So just draw a line. So like this from point 5 here. So join it with point O prime. And from point 4 here. So you draw the line. So connect it with O prime. And then so from point 3. So draw a line. Connect it to O prime. And from this point 2. So draw a line, connect it with O prime. So from point 1, so draw a line to join it with O prime. And from point 0, draw a line to touch O prime. So from point 11, so draw a line, connect it with O prime. So from point 10, so draw a line, join it with O prime. And then we do the same thing here from point 9. So draw a line, join it with O prime. From 8, we draw a line, so join it with O prime. From point 7, so draw a line and join it with O prime. So then, lastly, from point 6, so draw a line and join it with O prime here, like this. Alright, so with what we have here, so the next thing that we are going to do to round off this work, so what we do is to make this line from 6 to O prime, we make it a thick line, okay? And also from 6 here to O prime, so we also make this line, so we make it a thick line like this, okay? So what we see here is the surface development of a complete cone, as I said. It's as simple as I've done it here. All you have to do is to practice. Thank you, and keep on practicing. And note, you can erase this excess hack if you like, so that you can have this sector. What we need is just this sector. So this one is just an excess excess. I can erase it if you like, or you can leave it like that. There's no problem. So what we need has come out. So from here, so from this point 6 to this point 6 here, with this point O prime back to 6 is the surface development of this complete cone. Thank you, and God bless you.